Hey everyone, so I'm going to do a video on radicals because it'll help clear up a few things that you were confused about in class. So I'm going to go over adding, subtracting, multiplying, and dividing, and simplifying them. So the first question I have is the square root of 392 with x squared on the side of it. So the first thing you want to do is think of the perfect squares that are inside of 392. With this video, it might be a good idea to pause it and try the problem on your own, and then press play and see how I do it, so that might be a good idea. But anyways, as I was saying, 392, the highest perfect square I can think of is 49. So 49 times 8 gets you 392. And how I got that was I listed out all my perfect squares, so 1, 4, 9, 5 times 5 is 25, I have 16 in here as well, 6 times 6 is 36, 49, and so on. And I usually take the highest one I can think of that goes into 392. And 392 divided by 49 gets me 8. So anyways, square root of 49 brings out a 7, and x squared becomes an x. Radical 8 is not done yet because we all know that radical 8 can break up into 4 and 2. So really what I have here is 7 times 2 because of the 4, x radical 2. 7 times 2 is 14x radical 2. That's my first question. The next one, notice it is a cube root, so you have to think to yourself something times itself 3 times. So I'm going to break this up so maybe we can work with this easier. Okay, I want to think of a perfect cube inside of 16. Well, negative 8 is a perfect cube, and negative 8 times 2 gets you 16. The cube root of a cubed, 3 divided by 3 is a to the first, so we just get a. Now b to the eighth, I have to think of the first perfect number, or the perfect power, that will be able to be divisible by 3, because remember, power over root. 8 does not divide by 3 perfectly, so I'm going to think about the first power that divides by 3 perfectly, and that would be 6. So I'm going to do b to the 6th and b squared. 6 plus 2 is 8, so I really didn't change anything about this problem. Now I'm just going to simplify. The cube root of negative 8 gets you negative 2. And then 6 divided by 3 is 2, so I get b squared. And then 2 does not divide by 3. Remember, power over root, so 2 does not divide by 3, so I'm going to be left with the cube root of b squared. Now I'm just going to clean this up. Negative 2a b squared and the cube root of 2b squared. These go underneath the same radical because they're still inside the house. Alright. The next question asks you to add and subtract radicals. Remember, adding and subtracting radicals, you need to think of a few things. First off, you need to make sure that the inside, the radicands, are all the same. These are not all the same, so we're going to have to change them. And we also need to make sure that the indexes of our radicals are the same. These are all an index of 2, so I can definitely add the radicals. So what I'm going to do right now is simplify them. Radical 12 will break up into 4 and 3, because 4 is a perfect square inside of 12. 3 radical 3 is going to stay the same, and radical 20 will break up into 5 and 4. So now just simplify. Negative 3 times 2, because this becomes a 2, radical 3 plus 3 radical 3, plus 3 times 2, because this becomes a 2, and radical 5. Alright, negative 6 radical 3 plus 3 radical 3 plus 6 radical 5. Only add the ones that are like. These two are like because the radicals are the same. So negative 6 plus 3 gets you a negative 3 and keep the radical. You're just going to add 6 radical 5 to the end of it because he is not like, he does not have the same radicand, and that means that you cannot combine them any further. The next question is very similar. So again, you're going to want to get the same radicand for some of them and combine them. So I'm going to simplify all 3 of these, and hopefully some of them will combine. Negative 2 radical 6 does not reduce any further. It's simply itself, so I'm just going to rewrite him. 45 breaks up into 9 and 5, and 20 breaks up into 4 and 5. Again, think of the highest radical perfect square inside of that radical. I'm going to keep negative 2, square root of 9 becomes a 3. Minus 3 square root of 4 becomes a 2. Radical 5 minus 2 radical 6. Negative 2 times 6 is a negative 2 times 3 is a negative 6 radical 5 minus 6 radical 5 minus 2 radical 6. Again, only combine the radicals that are like, so these two are like. I'm going to combine their coefficients and get negative 12 radical 5 minus 2 radical 6. And that's your final answer. Next one asks you to multiply radicals. So to multiply radicals, this is the only time also with division that you can touch the inside of the radical, which is the radicand. So because we're multiplying, I can simply multiply the two numbers, so 6 times 2 gets me the square root of 12, and just reduce. So remember, multiply, then simplify. You get 2 radical 3. Same thing here. With this one, though, you have to make sure that your indexes are the same, and they are both 3. So I can multiply the cube root. 3 times 9 is 27, and the cube root of 27 is 3. 3 times 3 times 3 gets you 27. With the next one, you're going to distribute, and you're going to end up getting 12 radical 3, because remember, you're multiplying the coefficients, so 3 times 4 is 12, and then I'm going to multiply 3 times 3, actually a negative 3, so negative 9, and then a radical 3 times a radical 5 is a radical 15. This does not simplify any further because those numbers are not the same, 3 and 15. So I'm simply going to just box this off, and this is my final answer. The next one is going to require you to use the box method or FOIL, whatever you prefer. So what I'm going to do is write this guy at the top of my box, the first one, and then the second one on the side of my box. And I'm going to multiply. So negative 7 times 4 is a negative 28. I'm going to move this over so that it's neater. Okay, 4 times radical 3x is going to get you 4 radical 3x. Negative 7 times radical 3x is a negative 7 radical 3x. Again, I'm just multiplying the coefficient, which is 1, by negative 7, and radical 3x stays the same. And then radical 3x times radical 3x gets you a radical 9x squared. Now at this point, you can pull everything out of the box if it makes it easier for you to see what you're doing here. And at this point, you're just adding like terms and simplifying. So I see like terms here. These are both radical 3x's. So I'm going to keep negative 28, and I'm going to end up getting negative 3 radical 3x because of positive 4 and a negative 7 gets you negative 3. Now 9 comes out of the house as a 3, and x squared comes out of the house as an x. So this is my final answer. None of them can combine because 3x is just 3x, not radical 3x, so he does not combine with him. And he is not like any other ones here, and this is just a number, so this is your final answer. Alright, dividing radicals. Dividing radicals is similar to multiplying radicals where that you can touch the inside of the radical, the radicand. So for example 1, I'm going to be able to use division of just the inside. So I'm going to divide 48 by 3, and I end up getting 16 m squared. M squared doesn't divide by anything, so I'm just going to keep him inside. And then I'm going to think, what's perfect? If I break this up, I get 16 and m squared, and I get 4m. Okay, next one I'm going to also divide. So I'm going to keep the 3 in the denominator because he's not going to divide with anything in the numerator. It's really just 1/3. And I'm going to divide the numbers. 15 and 10 both reduce with 5. So 15 becomes a 3 and 10 becomes a 2. Now, when you divide, you subtract exponents. So x, it's to the first power, and x is also to the first power. So they become 1 minus 1 if you subtract the exponents, and that becomes 0. So really, x and x, they just cancel out to 1, and they don't really exist anymore. Now, what you're going to do with the y's, this is y to the first, really. Subtract 1 minus 3 is 2, so I get y squared in the denominator. Okay, I'm left with radical 3 over 3. y squared is perfect. 2 divided by 2, because the index here is 2, power over root, gets you y to the first, radical 2. Now the final thing you need to do is make sure that your answer is rationalized, meaning that there are no radicals in your denominator. The only thing that's causing a problem in this problem right now is the radical 2. So all I need to get rid of is him. And if you remember in class, when you have a monomial radical inside the denominator, you just multiply by itself. So I'm just going to multiply by radical 2, leaving me with radical 6 over 3y radical 4. Now you could also realize that radical 4 right away cancels out and becomes just 2. Simplify this, you get radical 6 over 6y. The next question, again, is very similar. This is basically done. The only problem with this question is that there's a radical 8 in the denominator. So again, he's the one causing the issue. So get rid of him by multiplying him by himself. This will go in to both of these. So I'll end up getting radical 8 times 3 is a radical 24 plus 3 radical 40. Okay. And then 2 times radical 64, because that multiplies here. Again, you can realize right away that a radical 8 times a radical 8 is just itself, so I can simply cancel this out and write an 8. So I have radical 24 plus 3 radical 40 all over 2 times 8. The only thing I need to do at this point is simplify. So let's simplify this answer. I end up getting 24 breaks up into 4 and 6, and 40 breaks up into 4 and 10. And 2 times 8 is 16. Okay, 4 becomes a 2, radical 6, plus 3 times 2, radical 10, all over 16. 2 radical 6 plus 6 radical 10 all over 16. The last thing you need to do is make sure you simplify your answer. And the easiest way to do it, I think, is to break it apart. This is legal because it's a common denominator of 16. And all you're going to do is reduce the numbers. Do not touch the radical, because radical 6 cannot reduce with a 16 because the 16 is not inside the house. So I can reduce this to 1 and this to 8, because 2 goes into 16 8 times, which leaves me with radical 6 over 8. And I can reduce 6 to a 3 and 16 to an 8, because they both go into 2. 6 goes into 2 3 times, and 16 goes into 2 8 times. So I'm left with 3 radical 10 all over just 8. These have the same denominator, so my final answer will be radical 6 plus 3 radical 10 all over 8. Okay, last question. Last question has a binomial inside of the denominator. So basically, you need to be able to get rid of that binomial. And if you remember from class, the way that you do that is you multiply by the conjugate of the denominator. The conjugate is the same thing as the bottom, just with the middle sign changed. So only the middle sign will be changed, not this one, just the middle one. So I'm going to multiply this by negative 2 plus radical 5, and negative 2 plus radical 5. You're more than welcome to do the box method twice, but if you remember from class, when you multiply by the conjugate, the middle terms cancel out. So with the denominator, the only thing I need to multiply is the first term and the last term. The first term, negative 2 times negative 2, gets you a positive 4. Negative radical 5 and a positive radical 5 gets you a negative radical 25, which simplifies nicely to 4 minus 5, and then we end up getting negative 1 in the denominator. Now what you got to do is figure out the numerator. I'm going to simply just multiply using the box method because they are not conjugates. I'm going to have to do the full multiplication. Negative 2 times 2 gets you a negative 4. Negative 2 times a negative radical 3 is a positive 2 radical 3. 2 times radical 5 is 2 radical 5. negative radical 3 and a positive radical 5 gets you a negative radical 15. What's left of this answer when you add the like terms, which, by the way, there are no like terms because radical 5 and radical 3 and radical 15 do not have the same radicands, you're going to write that answer at the top here. So minus 4 plus 2 radical 3 plus 2 radical 5 minus radical 15. And that's going to keep going across here until you get to the end. So I'm going to rewrite it on top of this negative 1 because that's the simplified version of the denominator. And there's actually only one more thing I can do because the numerator doesn't have any like terms. So the only thing I could really do is divide everyone on the top by negative 1, which basically just changes their signs. So negative 4 will become a positive 4. Negative 2 radical 3 becomes negative because it's positive originally. Then minus 2 radical 5 because it was positive originally. And plus radical 15. I hope this video helped. If you have any other questions, please come and ask me. Good luck, and I'll see you guys soon.